Hello everyone. In this video, we are going to discuss about two JEE questions which were asked from the chapter Electric Charges and Fields of Class 12 Physics. We will be discussing so many questions which were asked for the JEE and NEET examinations in the previous years from the same chapter Electric Charges and Fields of Class 12 Physics, but I cannot make it in a single video. So I will be providing all those short videos in our playlist, so you can just go through it. You can just go to the playlist and you will get all other questions. So let us start with the first question. Two charges each equal to Q. So there are two charges each of magnitude Q are kept at x equals minus a and x equals plus a on the x-axis, which is actually shown in this figure. You just consider this as the x-axis, origin, positive x-axis and negative x-axis. Okay, this point is a point which is at a distance plus a from the origin, and this point is at a distance a but along the negative x-axis, so it is minus a here, and there is a charge q here, there is another charge q here. A particle of mass m and charge q0 equals q by 2 is placed at the origin. So you see this is the origin O, and you see there is a charge q0 which is equal to q by 2 is there at the origin. Now if charge q0 is given a small displacement which is y less than a along the y-axis, that is the charge q0 was initially at the origin. Okay, here I have marked the y-axis as well. This is positive y-axis and the down one will be the negative y direction. So you see this charge q0 was initially here at the origin, and there is a small displacement for this charge now. The displacement is y. Okay, so there is a displacement for this q0 charge, displacement of y. Now this charge q0 is along the, some way here which is along the positive y direction. Now the question is, what is the net force acting on the particle? The net force acting on the particle is proportional to, there are four options given, which is proportional to y, minus y, 1 by y, minus 1 by y. So which one is the correct option? That is the question. So you see this is a question which was actually asked for the JEE main examination 2013. So here we should know about the net force acting on this charge q0. So you see there are two charges, one is q here, another one is q here. So there will be a force due to this charge q on this charge q0, and there will be a force on this charge q0 due to this charge q. Okay, so you see I am just marking a dotted line which is joining these two charges, and here as well. Okay, I am just drawing a dotted line which is along the line joining of these two charges. Okay, now you see, what about the direction of force acting on this charge q0 due to this charge q? Or before that, you see, we want to know about the net force. So you see, we know that force is a vector quantity which has a magnitude as well as direction. We will go to the direction later. First let us discuss about the magnitude of the force, the net force acting on this charge q0. So for that, you see, in general we know that, see, there are two charges. First I am taking this one, q and q0. These two charges are separated with a certain distance here. So the magnitude of that force between two charges, it is actually given by the Coulomb's force law, Coulomb's law, which is 1 by 4 pi epsilon 0 q1 q2 divided by r square, which is given by Coulomb's law for the magnitude of the force between two charges q1 and q2 separated by a small distance r. So let us apply this equation here in this case, the case of these two charges q and q0. So you see, this distance, it is already mentioned in the question, which is y, displacement y, that is the distance from q0 to the origin. Now what about this distance? A. Okay, it is minus a here because it is along the negative x-axis. So this distance is a. Similarly, from origin to this point, the distance is small letter a. So we can easily find out the distance between q and q0 now. We can apply the Pythagoras theorem here. You see, this is a right angled triangle. So hypotenuse, which is this, which is to be found out. So hypotenuse square is equal to base square plus altitude square. So a square plus y square or y square plus a square. So what about the hypotenuse? This will be root of y square plus a square. That is the distance between q and q0. This distance will be square root of y square plus a square. Similarly, the distance between q0 and q, this will also be square root of y square plus a square, because you see the same distance a here, the same distance y here. This is also a right angle triangle. You can apply the Pythagoras theorem here so that you will be getting the same answer here. Now you see, I am taking the magnitude of the force between these two charges q and q0 as, F1. So F1 equals 1 by 4 pi epsilon 0 charge q into q0 divided by square root of y square plus a square is the distance between them. So when we apply this equation here, we have to take the square of that distance. So square root of y square plus a square will be what? Y square plus a square. Okay, similarly, I am taking the magnitude of the force between q and q0. This side, that is I am taking it as F2. So that will be equal to what? 1 by 4 pi epsilon 0 product of the two charges. So q into q0 divided by square of the distance. So y square plus a square. Okay, so from this it is clearly understood that you see the magnitude of the force F1 and the magnitude of the force which is F2 both are equal. So I am just taking it as F. Okay, that is the force acting between q and q0. Its magnitude is F1. The force acting between q0 and q this side, its magnitude is F2. Both are equal in magnitude. So I am just taking it as F. Okay. Now you see, it was by mistake it was written as q0 equals q by 2. It is actually in the question it is minus q by 2. So please note that there is a slight change in the question. The charge q0 is actually minus q by 2. Okay, there is a negative sign here. So you see this charge q0, this is not q by 2, it is minus q by 2. Okay, in the question it was by mistake I wrote it as q by 2, but it is minus q by 2. Please note that. Here also I changed, okay, minus q by 2. So you see, there is a charge q here and there is a minus q by 2 charge here. There will be a force acting on this charge minus q by 2 due to this charge q. See, both are, one charge is plus, another one charge is minus. So there will be a force of attraction between them. So this charge q will try to attract this charge minus q by 2 along this direction. Right. Similarly, there is a charge plus q here, there is a negative charge here. So there will be a force of attraction between them. So the force on q0, which is minus q by 2, due to this q is an attractive force. That is, this charge q will try to attract this q0 charge along this direction. Okay, this charge q will try to attract q0. This charge q will try to attract q0 along this direction. Okay, so what about the net direction? See, we already know that here this force is actually F1, this force is actually F2. Okay, so when we consider this force F1, see, this is the y-axis, this is the x-axis. This F1 force is not just along the x-axis or not just along the y-axis. So we know that we have already learned in 11th standard that we can actually split this, or we can actually make it into components, right? See, this F1 force will have one horizontal component and this force F1 will have one vertical component. What about the horizontal component and what about the vertical component? See, I am just taking this angle as theta. Okay, I just took this angle as theta. Now, here if we find out sine theta. Sine theta equals opposite side. Opposite side means this side. This horizontal side. See, this horizontal side is actually equivalent to this. Okay. Divided by hypotenuse. Hypotenuse means, see, this is actually the force F1. So, F1. You should not take this distance here. Okay, it is a different case. We are talking about the component form of force. So, we have to consider this force F1 here. That is, this horizontal component is actually what? F1 into sine theta. That is, this is F1 sine theta. Okay, similarly, what about the vertical component, this component of F1? See, to get the vertical component, we just want to find out cos theta here. So, cos theta equals adjacent side. Adjacent side means the vertical component divided by hypotenuse, which is the force F1. So, this vertical component is what? F1 into cos theta. So, this vertical component is F1 cos theta. Similarly, you see, this force F2, it is along this direction. So, it will also have one x component, that is one horizontal component, and it will also have one vertical component. Here also you can take this angle as theta. Okay, so here also if you find out, cos theta, sine theta, the horizontal and vertical components, in the same way, you will get this horizontal component as F2 sine theta, and you will get this vertical component as F2 cos theta. You can just follow the same way. Okay, so you see, there is a force F1 sine theta acting along this direction. There is a force F2 sine theta acting in the opposite direction. You see, F1 and F2, they are actually equal in magnitude. Okay, so F1 sine theta and F2 sine theta, they cancel out each other. And you see, there is a force F1 cos theta along the negative y direction. There is a force F2 cos theta also along the negative y direction. So, they add each other. Okay, so the net force acting on this charge Q0 due to these two charges Q and Q will be what? The sum of these two. That is F1 cos theta plus F2 cos theta. Now, what about cos theta? What about the value of cos theta? Cos theta equals adjacent side, which is y, divided by hypotenuse. Hypotenuse is actually root of y square plus a square. Okay, so here we have the value of cos theta. Here we have the value of F1 and we have the value of F2. We just want to substitute all these to this equation. So, let us apply these to this equation so that the net force, it is equal to, this is just the magnitude, okay, F1 cos theta plus F2 cos theta. You see, F1 and F2, they are actually equal, which can be taken as F. Okay, so this becomes F cos theta plus F cos theta, which is 2F cos theta. Okay, so this will be equal to 2 into F means the force, either F1 or F2, because you see both are having equal magnitude, no? So, 2 into 1 by 4 pi epsilon 0, Q into Q0. So, Q into Q0, its magnitude, we can just take it as Q by 2. I am not taking negative sign here because we will discuss about the direction later. So, Q into Q by 2 divided by y square plus a square. Okay, so 2 into F into cos theta. What about cos theta? Cos theta is given by this expression, which is y divided by square root of y square plus a square. So, you see, this can be written as the net force is equal to 2 into 1 by 4 pi epsilon 0 Q into Q by 2. Okay, into 1 by y square plus a square into y by root of y square plus a square. So, you see this 2 and this 2, they get cancelled. Okay, so this actually becomes equal to 1 by 4 pi epsilon 0. Okay, then 1 by 4 pi epsilon 0 Q into Q square. Okay, y divided by y square plus a square into square root of y square plus a square. Square root of y, this is like y square plus a square into square root of y square plus a square means y square plus a square all raised to 1 by 2. So, this is like x raised to m into x raised to n, x raised to m plus n, that is 1 plus 1 by 2, which is 3 by 2. So, here you can write it as y square plus a square all raised to 3 by 2. Okay, so you see this is the magnitude of the net force acting on that charge Q0. That magnitude is 1 by 4 pi epsilon 0 Q square y divided by y square plus a square all raised to 3 by 2. Okay, so here it is very clear that the net force is directly proportional to y. But think about the direction of the force as well, because force is a vector quantity. That is, if we consider only the magnitude of the net force, we can write the magnitude of the net force is directly proportional to what? Y. Okay, but when we consider the vector form as well, what happens? Here you see the net force is actually acting. Net force is actually the sum of F1 cos theta and F2 cos theta. Both are along the negative y direction. Okay, so the net force, its magnitude is like, F net, its magnitude is proportional to y, but you see force is a vector quantity, it has a definite direction. You see the direction of that force, the net force is along the negative y direction. So you have to here you have to put one negative sign whenever we consider the whole force, the both the direction as well as the magnitude. So here we can write the net force acting on this charge q0 equals minus q by 2. It is proportional to minus y. So option B is the correct option. Now, let us discuss the second question, which was actually asked for the JEE examination, which was actually named as AIEEE 2012. So you see, this question is also asked from the same chapter, electric charges and fields of class 12 physics. So you see, the question is in a uniformly charged sphere of total charge q and radius capital R. The electric field is plotted as a function of distance from the center. So you can see three plots here, electric field versus the distance from the center of the charged sphere. It is not the shell, it is the charged sphere. Okay, now the graph which would correspond to the above will be, okay, A, B, C, D, 4 options are there. Which one is the correct option that you want to choose out? So you see, we already know that for a spherical shell, for a uniformly charged spherical shell, the electric field outside the shell is 1 by 4 pi epsilon 0 q by r square, and electric field inside the shell is 0. But in this question, it is actually based on a uniformly charged sphere. So uniformly, for a uniformly charged sphere, the electric field outside the sphere, it is similar to this, which is 1 by 4 pi epsilon 0 q by r square. That is for a uniformly charged sphere. Okay, see, the sphere is having a radius capital R, the charge is capital Q, and the distance from the center to that point we are considering, that is small letter r. So for a uniformly charged sphere, the electric field outside the sphere is 1 by 4 pi epsilon 0 q by r square. That is, electric field is proportional to 1 by r square. Now, for a uniformly charged sphere, the electric field inside the sphere is 1 by 4 pi epsilon 0 q by r cube into r. This r is the radius of the sphere and this is the distance. So, here we have plots of electric field versus the distance. So, in this case, inside the sphere, the electric field is directly proportional to, because you see this r is in the numerator, so it is directly proportional to r. So we have to consider these two. That is, outside the sphere. Outside the sphere means for distance which is greater than the radius of the sphere. Suppose this is the sphere. Okay, uniformly charged sphere. This is the center of the sphere. So outside the sphere means a point somewhere here. This distance is small letter r. So you see, outside the sphere means that distance is greater than the radius. Okay, now inside the sphere means the distance is less than the, inside the sphere means you can consider a point here. So this distance is less than the radius of the sphere. Okay, so for distance greater than the radius r, this must be used. E is proportional to 1 by r square. For distance less than r, that is inside the sphere, E will be directly proportional to r. So which graph would be, or which one, A, B, C, D, which one would be the correct option here? You see, this option C is the correct option here. Because you can consider, see, inside the sphere, E is directly proportional to R. That means that graph is a straight line graph. So here you can see a straight line graph. It is till this point only. That means this corresponding to this point, this distance is the radius of the sphere. Then for distance greater than the radius, that is outside the sphere, E is directly proportional to 1 by R square. E is proportional to 1 by R square. That graph would have, that. So in this video, we have discussed about the two JEE questions which were asked from the same chapter, electric charges and fields of class 12 physics. So I will be providing all other questions, that will be, you will be getting as different videos, but you will get it from the playlist. Okay, you can see a folder of electric charges and fees there. From that folder you will be getting all other questions as well. So I hope it is clear to you. Thank you.